everyone, it's Miss Rodriguez here, and today we're gonna go over converting measures. And hopefully if you follow directions right before this video, there were directions to copy down everything on this paper so that we could get a quicker start for our video. So if you haven't already done that, go ahead and pause the video, turn to the next clean paper in your notes book, and go ahead and copy everything that you see on the screen down. And then when you're done, come back and press play again, okay? All right, so for those of you that already have it down, and for those who are just coming back from copying it, let's talk about this for a second. So we're talking about converting measures. And this is something that you've done before. I just might show you a different way. You might have learned this way. This is really kind of a little bit of review, all right? So, there are two basic units of measurement, or systems of measurement, okay? And the system that we're most familiar with is the customary units, which is the standard measuring system, okay? And so this is like our ruler, right? This is an inch, okay? And we're really familiar with inches, okay? And then, so some other examples from our customary units are inches, feet, yards. You want to get really big distances, you use miles. When you're measuring liquids or food or even dry solids, you might use cups or gallons. Dry goods, you might measure in pounds, like a pound of sugar or a pound of flour. And there's many more, but those are the basic ones that we use very commonly. Okay, but the thing is it's really only the U.S., the United States. So you might have thought this says us only, which is kind of true, us Americans. But it's really the United States that use this system of measurement. Whereas the other system is used by most of the world. It's called the metric unit system. Okay, and so the metric unit system consists of things like millimeters, centimeters. Those are measuring length of something. Meters, if you wanted to talk about a really long distance, it would be kilometers. So if you ever heard of someone running a 5K race, that would be kilometers. Then there's liters. You could measure liquid with that. Grams, that's a weight, so maybe liquid or solids. Kilograms, that's also a weight. So those are some of the common ones as well. All right, and what we're going to just look at is how does the metric system work? So essentially, the metric system works with prefixes. So notice right here I have liters, I have grams, I have meters. Those are my base units. But then we use prefixes to change what they are. So I'm going to show you. The metric system uses base units such as grams or liters, and adds prefixes to change, we'll say size, or measurement. We'll say measurement, change measurement. Okay. All right, and now I'm going to show you kind of a little bit of how that works, okay? So let's just say we're going to start right here, and we're going to start with a unit. Remember when we did unit rate, what did we say unit meant? Unit means 1, okay? So a unit is going to equal 1. Okay? And then let's say, let's go big first, okay? Let's say we're gonna go to the next size bigger than 1, okay? That's gonna be called a deca, and it's D-E-K-A. And that's going to be times 10. So 1 times 10. Then let's go to a hecto. And that's going to be times 100. So hecto times 10, I'm sorry. Hecto would be 100 times 1. And then let's go to a kilo. That would be 1,000 times 1. Okay? So what are you talking about, Mr. Rodriguez? What do you mean times 1,000? What does that mean? Okay, so let's say your starting unit was a gram, or a liter, and we'll say ECT, etc., because it could be any one of their units, okay? So let's say it's a gram. If I have 1 gram, it's just a gram. If I have 10 grams, I have a decagram. I don't say 10 grams. So I would say I have 1 gram, 2 gram, 3 gram, 4 gram, 5 gram, 6 gram, 7 gram, 8 gram, 9 gram, and then I have a decagram. Okay? And then a hectogram would be 100 grams. And a kilogram would be 1,000 grams. Okay? And then anything in between those would be decimals. So I would or fractions. If I had let's say if I had 15 grams, I would have 1.5 decagrams or 1.5 decagrams. Okay. Now these go on. There's more that get bigger, but we're not going to concentrate on that because we only need to know a few, okay? And we just need to understand that they grow. But they also shrink, all right? So up here, you've got growing. They grow by base 10. Okay? But a gram might be a little bit big. What if you're measuring something really, really small? If you're weighing something really, really small? Or, for instance, maybe we're talking about meters. A meter might be like about yay big. But I have something that's about this big. So I need to go smaller. It's less than a meter. Okay? So to go smaller, first I'm going to go with deci. D-E-C-I. And deci means divided by 10. So that means there are 10 decimeters in a meter. Okay? Because 1 divided by 10 would be 0.10. Okay, now if I go even smaller, I would go with centi, and that's divided by 100. So if I have a meter, I think a meter is actually like a little bit bigger, but if I have a meter and I divide it by 100, then I get a centimeter. So I have 100 centimeters in a meter. Okay? And then I could go even smaller to a milli, which is divided by 1,000. And if I had a meter and I divided it by 1,000, I would get an itty bitty little millimeter on my ruler. You might be able to see it. You see, this is a centimeter. From 4 to 5, that's a centimeter. But all those itty bitty little marks in between, those are millimeters. Okay? So you've seen them before. You just probably never really think about how they break down from a meter. Okay? A foot is not a meter, just so you know. 1 foot does not equal a meter. Okay, so as you can see, as the numbers shrink, they shrink by base 10. All right, so if you can kind of memorize those as you're going through math, and remember that it would be kilo is times 1,000, hecto is times 100, deca is times 10, unit is 1, deci divide 10, centi divide 100, milli divide 1,000. If you can remember those, you'll be really good basically with the metric system for your everyday needs. Okay? Okay, and so just so you get an idea on which ones are like commonly used, which ones will you encounter a lot, you will definitely encounter the kilo. I'll put a little star there. Obviously, you'll encounter a meter, a gram, a liter. You will encounter centi a lot, a centimeter. And you will encounter a millimeter a lot. We don't all too often see decimeter, and we also don't see decameter or hectometer too often. They're not very widely used, okay? And so just so you remember what the asterisk means, commonly used. Okay. All right. Moving on. Second page. Now what we're going to do is we're going to do a conversion factor. Okay, so a conversion factor. So a conversion factor is a rate that equals 1. It's kind of like a unit rate, okay? So it's a rate that equals 1. And let's see. I'm trying to think of one that you might remember. Let's think of a gallon, okay? If you had 1 gallon, hopefully you remember that a gallon is equal to 4 quarts. Okay, so that is an example of a conversion rate. And we can also write it as a fraction, okay? So to write it as a fraction, it would be 4 quarts equals 4 quarts over 4 quarts equals 4 quarts to 1 gallon. That's how you would write it. So 4 quarts to 1 gallon is the same thing as saying 4 quarts to 4 quarts. Okay? Well, okay. And they all equal 1. Okay, so the reason why you might need a conversion rate right here is because you might need to know how many gallons are in a certain number of quarts, or how many quarts go in a gallon, or so forth. Okay, so let's look at an example. So example 1. Convert 36 quarts, just in case you guys don't know, that's my lowercase q, to gallons. All right, so remember, we know that there are 4 quarts in 1 gallon, right? Yes. So I can write 1 gallon to 4 quarts. Okay? And then on the other side, I have 36 quarts. Actually, I wrote that a little cuckoo, so erase that for a second, because I got all big and weird. Okay, 36 quarts. And I'm trying to figure out my conversion rate. Okay, so now what I do is called dividing by using the butterfly method. So I think this is going to be familiar to you guys. You should have learned the butterfly method for dividing a while ago. Okay, so butterfly method essentially means you're going to divide these two, and then you're going to divide these two. Okay, so if I divide 1 by 1, what do I get? I get 1. I don't need to do anything. I just get 1, okay? And then if I divide 36 by 4, I get 9. So 9 quarts. Make sense? Maybe, maybe not. All right, let's try another one. Example 2. Remember, pause it if you are still writing, okay? All right, so we're going to compare 25 ounces to 2 kilograms. We're going to try and figure out which one is bigger, okay? So that's what that box is. We're going to put a greater than or less than sign in there, okay? All right, so in order to do this, you need a conversion rate, and so let's go ahead and write that on the side. I know that 1 pound equals, anybody know how many ounces? Remember, we're looking for ounces. 16 ounces, okay? And then I also know that 1 pound, you might not know this by heart, equals 0.45 kilograms. Because I got to know what both of those measurements are in order to convert this, right? All right, now bear in mind that like on the EOG or something like that, they're always going to give you these conversion rates. You just have to know how to use them. So pretend like this is an EOG question and they're asking you to compare 25 ounces to 2 kilograms. And they are giving you this information, and now you got to use it, all right? So this is how we're going to use it. To compare different units, you have to make them the same, okay? So first, you have to make the units the same. So remember, we have ounces and then we have kilograms. They are not the same. We have to make them the same. So in order to do that, we are going to have to go from ounces to pounds first. Okay? So from ounces to pounds. If I have 25 ounces, and I know that there are 1 pound has, sorry, that's an L. 1 pound has 16 ounces. Remember that cross dividing? I know it says multiply, right? But instead we cross divide, okay? So I go okay? This cancels each other out. 1 and 1 cancel each other out, okay? So you're going to need your calculator for this. 25 divided by 16 is going to give me 1.562 ounces. I'm sorry, pounds. Make sense? Hopefully you checked it with your calculator. Okay, now I have it in pounds, the ounces are in pounds, and I have a conversion rate for pounds and kilograms, don't I? So now I can do the conversion rate for ounces and kilograms. So that's my pounds for the first one, 2.5. Ounces equals 1.562 pounds. Now I'm going to do my other conversion rate. And so now I'm going to take my 1.562 pounds and then I'm gonna do 0.45 kilograms to 1 pound. And notice that now I have a 1 and 1 on the bottom, right? So when I multiply straight across. So 1 times 1 is 1, so I can drop that, right? So now I'm just looking at the top number. So the top number is going to be 1.562 times 0.45 kilograms. So when I multiply that, I am going to get 0.703125 kilograms. Sorry. Hopefully you're doing that with your calculator. I multiplied straight across. And now I need to compare which one is bigger. Okay, so I did all of this so that I could figure out what that 25 ounces would be in kilograms. Okay? Now that I did that, now I can compare this amount of kilograms to this amount of kilograms. So if I have 0.703125 kilograms, and I'm comparing it to 2 kilograms, how would I know which one is bigger? Well, obviously this, because there's a decimal at the beginning, it's less than 1, right? If it's a decimal, it's less than 1. So that means this is smaller. So my alligator has its mouth open towards the 2 kilograms. So it is less than 2 kilograms. Okay, I know that's really confusing, but don't stress. You're not going to be tested on this. We're just going to practice it a little over the next day or two. And you're just going to remember to always pay attention to what the conversion rate is and have the conversion rate help you solve the converting, okay? Like I said, this is really a practice type situation, so don't stress over it. I know that it is confusing. You'll go into better conversions in 7th and 8th grade, but right now we're just kind of dipping our toes in the water. And if it seems confusing, hopefully after you practice a couple from our practice activities, you'll see that the questions really aren't that hard. Okay? All right. Have a good day, guys.